Hello students, today we'll be solving the IB Math EA till May 2024 paper 3 time zone 1 question number 2. You will be getting the solved past paper questions, the first question of this paper and the other solved past paper questions of the other papers in form of playlists on my channel NS Online Math Tutoring Classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I'm an online IB Math EHL level tutor. In case you want to join my classes, please contact me for more details. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start answering question number 2. The maximum mark is 28. This question investigates a ratio of lengths found from the line passing through the points of inflection of a quartic curve of the form y equal to x to the power of 4 minus mx cube plus nx. The curve y equal to x to the power of 4 minus 3x cube plus 3x has points of inflection at B and C. The line passes through B and C and intersects. The line passing through B and C intersects the curve again at points E and D. This is shown in the following graph. So part A's question is find d2y by dx square, the second derivative of y with respect to x. So, first of all, the expression for y, it is y equal to x to the power of 4 minus 3x cube plus 3x. Okay. So, therefore, the first derivative is dy by dx. The power will be coming down. So, 4 and the power gets reduced by 1. So, it is x cube. This also the power will be coming down and there is this 3. So 3 times 3 is 9 x square and plus 3. Now the second derivative. Equal to 12x square minus 18x and the derivative of 3, it is a constant term, is 0. So this is the answer for the subpart A. Okay. Subpart B, find the coordinates of points B and C. It is containing 4 marks. B and C are the points of inflection. So the second derivative should be equal to 0. So since B and C are the points of inflection, therefore d2y by dx square will be equal to 0. So implies the expression for d2y by dx square is this. So 12x square minus 18x will be equal to 0. And if I take out 6x as the common factor, I am having 2x from the first term and it is minus 3 from the second term equal to 0. And so this means either 6x equal to 0 or 2x minus 3 equal to 0. So implies x equal to 0 or 2x minus 3 equal to 0. Okay. Implies x equal to 0 or x equal to 3 over 2, or you can write it as 1.5, whatever you want. Okay. So now these two are the two x coordinates of the points B and C. We need the y coordinates also. And from the graph, we are seeing that the x coordinate of point B will be equal to 0 and the x coordinate of the point C will be equal to 1.5. Okay. So now we need the y coordinates. So y coordinates, okay, first of all, let me write the x coordinates of these 2 points. Therefore, x coordinate of B is 0 and x coordinate of C is 1.5. Okay. Now the y coordinates. Y coordinate of b is equal to, I have to substitute 0 in place of x. Wherever we are having x in the expression, I have to substitute 0. So it is 0 to the power of 4 minus 3 times 0 to the power of 3 plus 3 times 0 is equal to 0. Therefore, b will be 0, 0. Okay, now the y coordinate of c, I'm not seeing the function expression, but I'm seeing the zeros. Wherever there is the 0, I'll be substituting 1.5. Okay, so equal to 1.5 raised to the power of 4 minus 3 times 1.5 raised to the power of 3 plus 3 times 1.5. So this should be equal to, it should be a negative number because the y value, y is, or the point C is below the x-axis. So it will be now, I need the expression because I cannot see this part, my writing. So I need the expression. Okay. So in place of x, I'm writing 1.5. So 1.5 raised to the power of 4 minus 3 times 1.5 raised to the power of 3 plus 3 times 1.5. Enter. Negative 0.5625. Okay. So this is negative 0.5625. So therefore, C 1.5 and negative 0.5625. Okay. Fine. So part C show that the equation of the line 2B and C is y equal to negative 0.375x. Okay. So let me write the answer over here. Okay. So we know that the line is passing through the point 0, 0. So the y-intercept has to be equal to 0. So let me write that. Since, okay. So since the line passes through zero comma 0, therefore the y-intercept is 0. Not intercepts, intercept is 0. Okay. Gradient, we need the gradient and the y-intercept. Y equal to mx plus c. M is the gradient and C is the y-intercept. So gradient will be y2 minus y1 over x2 minus x1. And let me just write the coordinates. This is 0, 0 and this is 1.5 and negative, most probably 0.5625. Yeah, 0.5625. Fine. So let this B be x1 comma y1 and C be x2 comma y2. So y2 minus y1 is negative 0.5625 and minus 0 over 1.5 minus 0. So let's see the answer. Okay. So it is minus 0.5625 minus 0. I'm not writing that part. Over 1.5. Negative 0.375. Negative 0.375. Okay. So therefore, the equation of the line is y equal to negative 0.375. 2.375x plus 0. I'm not writing that part, obviously. Shown. Okay. So, part D, find correct to 3 decimal places the x coordinate of the point D. It is containing 2 marks. Okay. So part D, the curve and the line, they are intersecting at 4 points. One of them is the point D, the rightmost point. Okay, so let us equate the two expressions. So the curve's expression is x to the power of 4 and minus 3x cube plus 3x is equal to negative 0.375x. Okay, and we have to solve for x. Obviously, we will be using the calculator. We can solve this using graphs. We can draw this graph and this graph separately, and we can find the points of intersection, and there will be 4 points of intersection, and we will be getting the x coordinate of the rightmost point of intersection. That is one of the ways. Or else we can add plus 0.375x to both the sides, so the right side will be equal to 0, and we will be having 4 terms on the left side, and we will be graphing those 4 terms, so there will be a single graph, and we will be getting 4 zeros. So we will be taking the x coordinate, the 0, the 4 0, the rightmost 0, that will be the x coordinate of the point D. That is the second solution. These two are two graphical solutions, but this time I want to solve this algebraically. Okay, so, and I'll be using the TI-inspired CX2 calculator. So I'll be using the nsolve command. So let's see. So menu and then algebra 3 and then number 1 and numerical solve nsolve. So I'll be entering the equation x raised to the power of 4 minus 3 x raised to the power of 3 plus 3x equal to negative 0.375x, and then I have to declare the variable, so comma x, okay, and enter. It is 0. Of course, one of the solutions is indeed equal to 0, which is the x coordinate of the point B. This is the problem with nsolve. If you have multiple solutions of the given question, rather equation, the nsolve will be giving you one of the solutions. It usually gives the leftmost solution, but sometimes it gives other solutions as well. It has seen that 0 solution is the nicest one, so it has given the solution as 0. So, but we need the x coordinate of the point D. So how can we get the x coordinate of the point D and no other x coordinate? Because there are 4 x coordinates of the 4 intersection points. We need the x coordinate of the point D. So therefore, we have to add some constraint, some restriction. Okay. So what can be the restriction? The restriction can be, we know the x coordinate of the point C, it is 1.5. So we know that the x coordinate of the point D will be more than 1.5. We will be imposing this condition, this restraint. Okay. So let me just bring this down. Okay. And now I will be adding the condition. So there should be the pipe. Yeah. And then it is x should be greater than 1.5. So again, greater than 1.5. Enter. Now you see the solution is given as 2.42705. They have asked to give the solution correct to 3 significant figures. 3 decimal places. So the answer will be 2.427. Okay. So using GDC nsolve, the x coordinate of D is 2.427, most probably. Yeah, 2.427. correct to 3 decimal places. Okay. Now consider the general curve y equal to x to the power of 4 minus mx cube plus nx, where m and n are real numbers and m is greater than 0. So part E's question is find the x coordinates of the 2 points of inflection in terms of m. 2 points, they are not naming them as B and C. X coordinates of the 2 points of inflection in terms of m. It is containing 3 marks. Okay. E. Again, I am writing the expression for y. It is x to the power of 4 minus mx cube, because I have to get the second derivative. Therefore, dy by dx is equal to 4x cube minus 3mx squared plus n. So, therefore, the second derivative will be equal to 12x squared minus 6mx. Okay, and this should be equal to 0. So again, I can take out the 6x common. Sorry, it is x. And from the first term, it will be 2x. From the second term, it will be m minus m equal to 0. So implies 6x equal to 0 or 2x minus m equal to 0 implies x equal to 0 or x equal to m over 2. Okay. So therefore, the x coordinates of the 2 points of inflection are 0 and m over 2. Okay. Let these points of inflection be B and C. The line passing through B and C intersects the curve again at points A and D. Let XA be the x coordinate of point E and similarly XB, XC and XT. It is given that XC is less than XB is less than XC is less than XT. Subpart if it is containing 2 further subparts, the subpart I's answer is, question is, write down the coordinates of B containing just a single mark. Coordinates, so both the coordinates. Okay. So since XB is less than XC, therefore the x coordinate, because I have got the x coordinates of the 2 inflection points as 0 and m over 2. So why am I saying that the x coordinate of point B is 0? Because xb is less than xc. And m is a positive number, so m over 2 will be a positive number which will be more than 0. So x coordinate of B is 0. Therefore, the y coordinate of B will be equal to, now I'll be substituting 0 over here in this expression. So it is 0 to the power of 4 minus m times 0 cube plus n times 0 is equal to 0. So therefore, B 0 and 0. Okay. And now I. Find in terms of m and n the coordinates of C containing 2 marks. The x coordinate of C is m over 2. Therefore, the y coordinate of C is equal to wherever there is, or I can still see this equation or expression, or else I can just substitute m over 2 in place of 0. So it is m over 2 raised to the power of 4 minus m times m over 2 raised to the power of 3 plus n times m over 2. So this is equal to m to the power of 4, and 2 to the power of 4 is 16. And this is m cube times m is m to the power of 4. And 2 cube is 8. And this is, you can write nm, or I'm writing mn over 2. And this is m to the power of 4, and this is m to the power of 4. These are like terms, so I can group them. I can get a single term out of these two terms. So the denominator has to be 16. So it is m to the power of 4 minus 2m to the power of 4 and plus mn over 2. So this is, I'm writing the positive term first, plus minus m to the power of 4 over 16. Okay. So therefore, C m over 2 and mn over 2 minus m to the power of 4 over 16. Okay. So part G, show that the equation of the line through B and C is y equal to negative m cube over 8 plus n whole multiplied by x containing just 2 marks. And these are the coordinates of the points B and C. We have found these, and this was the equation of the curve given to us. M was greater than 0 and x, say the x coordinate of the point A was less than the x coordinate of the point B, which was less than the x coordinate of the point C, and x coordinate of the point C is less than the x coordinate of the point D. Okay. So, since the line passes through 0, 0, therefore, the y-intercept is 0. Now we have to find the gradient equal to y2 minus y1 over x2 minus x1. So I'm taking this as x1 y1 and this as x2 y2. Okay. So y2 minus y1 is mn over 2 and minus m to the power of 4 over 16. This minus 0 over m over 2 minus 0. So I can write this as, I can just take out this m over 2 rather. Okay. So let me take out this m over 2. And it is n from the first term. And from the second term, it will be m cube over 8. This is getting divided by this one, m over 2. So this is equal to m over 2, n minus m cube over 8 times 2 over m So this is equal to n minus m cube over 8. Okay. So this is the gradient. Therefore, the equation of the line is y equal to mx. So it is n minus m cube over 8x plus 0, which is, or y equal to, since this is written first, so I have to write this first, m cube over 8 plus n x. Okay, shown. Okay, h. Show that xa means the x-coordinate of the point E is m over 4 minus m over 4 times root 5. It is containing 7 marks. Okay, so we have to do this. H. Okay, so this is the curve's equation. Okay, and we know that this line is cutting the curve at 4 points. Okay, so for every intersection point, the y coordinates will be the same. So I can just equate the expressions. So it is minus m cube over 8. I'm just expanding. Plus nx. This is the line's equation. And x to the power of 4 minus mx cube and plus nx. Okay. So this is the equation. And now we see that the nx and nx, I can cancel these two, or I can subtract nx from both the sides. Okay. And so I am getting the expression as in this form. X to the power of 4 minus mx to the power of 3 and plus m cube over 8 x is equal to 0. Okay. And if we just graph this, we will be getting 4 zeros, and the x coordinates or the zeros will be giving us the x coordinates of the 4 intersection points. But we cannot just see using the GDC graphs because it is containing 7 marks, so we have to show the algebraic working. Therefore, I can, first of all, I have to solve this equation, and it is a quadratic equation. I do not know how to solve it. So I am saying that x is common in all the terms. So let me just take out x. I want to reduce the degree of the equation or the expression, because I know how to solve a quadratic equation, not a quartic equation. So this is x cube minus mx square plus m cube over 8 equal to 0. But again, this is a cubic expression. Either x will be equal to 0 or this will be equal to 0. So let me write this. Either x equal to 0, and I know that x equal to 0 is the x coordinate of point B, but I need the x coordinate of point E. So I have to solve the the cubic expression. X cube minus mx square plus m cube over 8 is equal to 0. Okay. And I have to somehow bring the degree down to quadratic, means 2. How can I do that? I know the x coordinate of the point C. So that will be this one, m over 2. This is the x coordinate of the point C. So since the x coordinate of C is m over 2. Therefore, x minus m over 2 will be a factor. Okay? Because I have to bring it down to a quadratic form. So, I will be doing the long division. So, therefore, x minus m over 2 and it is x cube minus mx square plus m cube over 8, but there isn't any term containing x, so I have to add the term containing x. This you have to remember. For the dividend, you should be having every term of x present. So I am adding this 0x because 0x is 0 and I can add 0 or subtract 0. It doesn't change anything. So this is plus 0x plus the constant term m cube over 8. Okay. And then I'll be dividing the first term of the dividend with the first term of the divisor. So I get the first term of the quotient. It is x square. And I'll be multiplying every term of the divisor with the first term of the quotient. So it is x cube. And I'll be writing the products under the like terms. So it is x cube and then x square times negative m over 2 is negative m over 2 x square. Okay. This is x cube and that is x square. So now I'll be subtracting. So I have to change the signs. It will be, these two will be getting cancelled and this is minus mx square and this is plus m over 2 half mx square. So the resultant will be negative m over 2 x square. And now I bring down the plus 0x. And again, this is the first term of the dividend. This is the first term of the divisor. I divide and I get the second term of the quotient, which is negative m over 2x. And I'm multiplying this with every term of the divisor. So it is minus m over 2x square. And minus m over 2 times minus m over 2, it is plus m square over 4x. Subtraction, so I'll be changing the signs. And this is minus m square over 4x plus m cube over 8. So this is minus m square over 4. So minus m square over 4x and minus m square over 4 times minus m over 2 is plus m cube over 8. Again, subtraction, the signs will be changing. So the remainder is 0. Okay. So I can write this as therefore x cube minus mx square plus m cube over 8 can be written as x minus m over 2 and x square minus m over 2x minus m square over 4. Okay. And this is of course equal to 0. So I have got the x coordinate of the point C. It is m over 2. I don't have to solve this part. I have to solve this part. I have to get the x values. So, and now it is a quadratic equation. I can use the quadratic formula. Therefore, x equal to minus b. So, it is m over 2. Minus of minus m over 2 is m over 2. Plus minus b square. So, minus m over 2 whole square. It is m square over 4. And minus 4 times 1 times minus m square over 4. Okay. Over 2 times 1. 2a. So this is m over 2 plus minus, this is m squared over 4, and that is plus m squared over 4. Sorry, 4m squared over 4. I'm not cancelling because the denominator is 4 for both the terms. I'm not cancelling. So this is equal to, divided by 2. So this is equal to m over 2 plus minus 5m squared over 4 divided by 2. So implies x equal to m over 2, or m over 2 plus minus, and this is, there is the 4 in the denominator and it is within the square root, so I can take out the half and I can take out m also. So it is m over 2 and root 5 divided by 2. So this is equal to m over 4 plus minus m over 4 root 5. Okay. So since xe is less than xt, therefore xe is equal to m over 4 minus m over 4 root 5. See, this is what has been given. M over 4 minus m over 4 root 5. Okay. Show that, right? Yeah. Fine. Coming to the last subpart. Okay. Hence, find the exact value of xb minus xa over xc minus xp. Exact value means it should be a numerical value. Most probably the m's will be getting cancelled. Okay, so let's see. It is xb minus xa over xc minus xb. So I it is xb minus xa over xc minus xb equal to, okay, let me see once more. Xb minus xa and xc minus xb. Yeah. So xb was 0 and xa is this one. So minus, I'm copying from this. So minus m over 4 minus m over 4 times root 5 over xc was m over 2 minus 0. So this is equal to m over 4 root 5 minus m over 4 over m over 2. So I can take out m over 4 common from the two terms of the numerator, and it is root 5 minus 1, and this can be written as divided by m over 2. Okay, so this is m over 4 root 5 minus 1 times 2 over m. These two will be getting cancelled and this is this. So this is equal to root 5 minus 1 over 2. So this is the exact value of xp minus xa over xc minus xb. Okay. So we have completed answering this question number 2. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please subscribe to my YouTube channel in case you have not subscribed to my channel till now. It will be motivating me and it will be telling the YouTube that my video is worth watching, so the YouTube will be showing my video to more number of students, more number of people. So you will not only be helping me, you will be helping others as well, and this will be helping me a lot. Your liking, sharing and subscribing will be really helping me a lot. We meet again very soon in our next session. We'll be solving the paper 1 time zone 2 of May 2024. So till then, bye.